Hello. In this video, you are going to learn hypothesis testing using z-test for the difference of two proportion. Two important objectives of this video are how to conduct z-test about the difference between two proportion using p-value method, and you'll also learn how to find p-value using TI-84 calculator. Before we begin this test, there are a few things that you need to know. Some of the important things that you need to know are, when you're performing the test for the difference between proportion, both samples must be random samples. If we randomize the sample, or if we select the sample using random, then the samples will be representative of the population. Next thing, the sample data are independent of one another. So there should not be any kind of relationship between sample 1 data and sample 2 data. Next thing, as we are dealing with the proportion, n times p must be greater than or equal to 10, and n times 1 minus p, sometimes referred to as q, is greater than or equal to 10. And while performing the test statistic is calculated using this formula here, where z equal to p hat sub 1 minus p hat sub 2 minus p1 minus p2, all divided by the square root of p bar q bar times 1 over n1 plus 1 over n2, where p bar, which is here, is x1 plus x2 over n1 plus n2, and then q bar is 1 minus the p bar. And you already know p1 hat is x1 over n1 and p2 hat is x2 over n2. Okay, let's take an example. Here is the example. A survey of 60 students at CCA found that 36 own a house. Another survey of 50 students at CCD found that 28 own house. At alpha equal to 0.05, is there a difference in the proportion? Okay, let's see how we can solve this. There are two samples here. The first one is the survey of 60 students at CCA. So that is my sample 1. Let me consider that as sample 1. And the other survey of 50 students at CCD, let's consider that as sample 2. Sample 2. Okay, first thing, let's find out what we know here. P1 hat, the proportion of a student at CCA who own house is 36 out of 60. 36 out of 60, which is equal to 0.6. Similarly, P2 hat. P2 hat is the proportion of a student who own house at CCD. Okay, student at CCD who own house. That is 28 out of 50. 28 out of 50, which is equal to 0.56. Later in the test, we need P bar, which is given by the formula x1 plus x2 divided by n1 plus n2. x1 36 at CCA, x2 28 at CCD, divided by sample size 60 plus 50. 36 plus 28 over 60 plus 50. So if you simplify this must be 0.5818. So your P bar is that. So if you want to find Q bar, or 1 minus P bar, that is equal to 1 minus 0.5818. And by subtracting this, we get 0.4182. So we have everything ready to perform the hypothesis test. Our question is, at 5% significance level, or alpha equal to 0.05, is there a difference in the proportion? So our null hypothesis will be, null hypothesis, which we write as H sub 0, always contain equality sign. So we say these two values, okay, these two values, P1 is equal to P2, equal proportion. So your alternative hypothesis, let me write here, alternative hypothesis, we write as H sub 1, or sometimes HA, is the proportions are not equal. And we are testing if there is a difference in the proportion. So we are testing this one, this difference, and we call that our claim. Okay, so we have our null hypothesis, we have the alternative hypothesis. Now we are going to find the test statistic using this formula here. Okay, let's work on that in next slide here. Okay, now let's use that formula. Our formula was Z equal to P1 hat minus P2 hat minus P1 minus P2, P1 minus P2, all divided by the square root of P bar times Q bar multiplied to 1 over N1 plus 1 over N2. Let's plug in the values. P1 hat, as we have calculated in the previous slide, is 0.6 minus P2 hat is 0.56 minus this difference, P1 minus P2. If you look at the null hypothesis, we stated that they are equal. So the difference must be 0 divided by the square root of P bar is this value, which is 0.5818, and Q bar is this one, 0.4182. So let's write those values. 0.5818 times 0.4182 multiplied to 1 over N1 is 60 plus N2 is 1 over 50. Okay, all these values are inside the square root and in the denominator. So this implies, if you simplify this giant expression using calculator, please pause this video and give a try. You should get 0.4235. Make sure you try that in your calculator. So that is the Z value, or the test statistic. Now what we are going to do is, as we are using the p-value method, we need to draw the rejection region over here. And if you look at the alternative hypothesis, it contains not equal to sign. Meaning of that is this is a two-tail test. And the Z value is 0.42, pretty close to 0. So 0.42, Z value of 0.42 should be here. This is 0.4235. Because it is a two-tail test, I need the negative value here. This value, this one, is negative 0.4235. So the sum of this area on the left tail, okay, and this one on the right tail is our p-value. Because of the symmetry, the areas on the tail will be equal. So let's find this area first, the area on the left tail. For that, we are going to use our calculator, TI-84 calculator. So we'll do second, then distribution, okay, and then number 2. Lower limit is negative infinity, so negative E99, that's good. The upper value is negative 0.4235, mean 0, standard deviation 1. If we paste that, the value we obtain is 0.3360. Okay, 0.3360, and this one is the same, 0.3360. So your p-value is 0.3360 on the left tail plus 0.3360 on the right tail, which is equal to 0.6720. That's our p-value. So we use the ordinary calculation procedure, that is, using this formula, we got the p-value here. You can check this value directly using calculator. Let me show you that. So in your calculator, go to stat, then test, and we are performing this one, 2 proportion z test. So 6, here x1, you can see it is 36 out of 60. So 36, x1 is 36, n1 is 60. For the second sample, it was 28 out of 50. So 28, 50. And then select the alternate hypothesis. It contains not equal to sign. And then you can directly calculate, or you can even draw. So if we do that, you can see this graph here. It matches with our graph that we have drawn here. Okay. And you can see the z value that we have calculated, 0.4235, and the p value is this area, sum of these two areas. You can see p is 0.6719, fairly equal. So you can directly calculate this p value using calculator if you want, but I'm showing you both ways so that you know exactly how to perform whenever you want to use either of the methods. Okay. After we have the p-value, we are going to compare this. So what we get is our p, which is 0.67, is actually more than the significance label. So p is greater than alpha. Okay, since p is greater than alpha, we fail to reject the null hypothesis. We are not rejecting the null. Instead, we are rejecting the claim. We are not rejecting the null. Okay, so we fail to reject the null hypothesis. Let me write that. We fail to reject the null hypothesis. We fail to reject the null hypothesis. Okay, we are not rejecting the null hypothesis. We fail to reject the null hypothesis. Meaning of that is, we are supporting the claim. That means there is enough evidence to support the claim that there is a difference in the proportion. Let me write that. Okay. Okay, let me make you a little bit clear here. We fail to reject the null hypothesis. Okay. We fail to reject the null hypothesis. That means we are not rejecting the null hypothesis. Instead, we are rejecting the claim. That means there is not enough evidence to support the claim. Okay, there is not enough evidence to support the claim. So let's see what we have learned in this video. Summary of this video. In this video, you learned how to conduct z-test about the difference between two proportions using p-value method. And also you learned how to find the p-value using TI-84 calculator. Okay, that is the end of this video. Thank you so much for watching.